Okay, I accidentally ended that video too soon too. I've been putting my finger in the wrong place. We'll try to stop putting my finger in the wrong place. So first two videos for today, a little shorter than I meant them to be, but that's okay. And I don't have enough skills to put those into one video, so you just got two short videos there. Anyway, so we are practicing the power rule, multiply by the exponent, decrease the exponent by 1. So working on that some more. And here's why we did our practice. I don't see an exponent, but I can rewrite that very easily to include an exponent. So that's 1 over x to the 2/3. And then my rule about x, power rule is when x is in the numerator, not in the denominator. So I immediately rewrite this to x to the negative 2/3. Fractions are going to be harder to deal with than non-fractions. So anytime we can rewrite an expression to avoid a fraction by using negative exponents, we're going to do that. So there's my simplified original function. And so that's still the original here. And so now the derivative, multiply by the exponent, decrease the exponent by 1, simplify, and so that's negative 2/3 x to the negative 5/3. Now what answers should look like, and this is just standard, that we want our answers to be as close in format as possible to the original problem. The original problem was in radical format. So the standard accepted practice is to return the answer, in this case to radical format. Well, radicals are best done with positive exponents. So returning this to a positive exponent, I drop the x to the denominator because that negative 5/3 applies only to the x, so I drop that to the denominator. And then I return that to radical format. And there's a good enough answer for me. Now, if you had a really hardcore algebra teacher in the past, a hardcore algebra teacher is going to tell you that that is not simplified and you need to simplify it further. It is technically not simplified because this exponent of 5 is greater than the index of 3. Yeah, I don't care about that. This is a good enough answer. Now, if you type this answer in and MyLab Math doesn't take it, that they even simplify this further, you can just write me and tell me, well, they simplified it further, I didn't, can you give me credit for it? And I will look at your answer, and if your answer's right, I can adjust your score. And that's true about anything that you think that, the computer took the answer to the absolute furthest it could possibly take it, and you think that you took it far enough but didn't make the computer happy, you can just write me and say, my answer's right, but it's not simplified enough. And I will look at it, and if I agree, I can adjust your score to reflect that problem is correct. Don't write me about adjusting your score until you're completely done with the assignment, because once I adjust your score, you will be locked out of the assignment. So once you're done, if you think you just need an adjustment, write me and I can tell you about it. Now, am I right? Am I wrong? You think you're right, but it doesn't quite match. One thing you do for a quick check, take a number, plug it into your answer, plug that same number into the answer that MyLab Math gave, the same answer the computer gave, and if you get the same result, so you plugged 1 into your answer and you plugged 1 into MyLab Math answer, and you get the same result, it is probably the same answer. I say probably because maybe you picked the one number where the two expressions happen to be equal, but it's probably the same answer. A better check, but takes longer, graph your answer, graph the answer from the computer, same graph, same answer. But if you ever think that it's a matter of simplification and the computer just counted it wrong because it went gung-ho on simplification, you didn't, just write me, I can check it out, and if you're right, I can adjust your score. But the standard format of what I'm looking for will be something like this, that since the original problem is in radical format, we return the answer to radical format. Okay, so that was the power rule. Next rule, the derivative of c times f of x is c times the derivative of f of x. In words, numerical coefficients can be factored out. And I have factored out in parentheses there, but that is actually what is happening. That if we went through the proof of this, you actually are factoring out that c. So the point here is this, that I can just leave that 3 alone. I don't have to think about it. Write it down. It's part of the answer, but I really don't have to think about it. Then just do the x to the 5th. Multiply by the exponent. Decrease the exponent by 1. Do basic simplification, we get 15x to the 4th. But notice my power rule would have worked just fine as far as multiply by the exponent. 15, decrease the exponent by 1. So let's recall before that we did learn this, that the derivative of x is 1. So this guy, the 2 just stays the 2. Coefficients can just stay there. They can just hang out. Then we remember that the derivative of x is 1. And so we get 2 times 1, or 2. And we could do this a couple more times, but we want to get to the point. So the derivative of 2x was 2. We could do the same thing for the derivative of mx. Derivative of x is 1. So what we're doing in both those cases, derivative of x equals 1, and we did that there too, that the derivative of x equals 1. And so we just get m. And so the point that we really want to get here, because you don't want to do that every single time. What you want to remember is this. The derivative of a coefficient times x, or y, p, q, is the coefficient. That's what you want to remember there. Okay, a couple more problems. Watch where I put my finger so I don't accidentally stop the video. What I did the first 2 times, not that you care, there's no one in the room, I don't know who I'm talking to, but you guys might be watching it. There's an SD card right in front of my finger that it records to, and the 2 times the videos ended prematurely, I ejected the SD card accidentally. I'll try not to do that again, but I can't promise that. Okay, working with this some more. First thing we want to do, anytime you can rewrite the original function so it doesn't involve a radical, so it doesn't involve a fraction, you do that. Exponents are easier than fractions, and we're always going to rewrite radicals. So we'll do 2 steps here. That's 3/4 x to the 1/2. That doesn't much look like a 1/2. And then I honestly don't care about that 4 in the denominator. I care about the x in the denominator. So moving only the x, I get x to the negative 1/2. And remember that exponent of 1/2 applies to the one factor to which it's adjacent. So the 1/2 only applied to the x, and I do not need to move the 4 anyway. So now the derivative. The 3/4 is just a coefficient. It just stays there. You don't really have to worry about coefficients. Just write them down. Now deal with the x to the 1/2. Multiply by the exponent. Decrease the exponent by 1. And then let's make it look as close as possible to the original problem. So that's negative 3/8 x to the negative 3/2. Then the original problem was a radical, so I should try to return the answer to a radical. So that's going to be negative 3 over 8x to the 3/2. That radicals go with positive exponents. So take that exponent back to the denominator. And so that's negative 3 over 8 times the square root of x cubed. Okay, last one before we get to a new rule. Again, let's recall something we already know, that the derivative of e to the x is e to the x, which is not what I quite have there. I have e to the negative x. So we simplify this first. 16 divided by 2 is 8, and then I can move that e to the numerator as long as I change the exponent to positive, and so my original function is the same thing as e to the 8x. Haven't done any calculus yet. That is still the original function. But it's now in a format that makes calculus really easy. The 8's just a coefficient, and then you just memorize. I have my notation wrong here, down here. Let's fix this. You just memorize, and you trust the world when we tell you the derivative of e to the x is e to the x. And so I get 8 times e to the x. Now, chances are everybody in the whole wide world would just accept that as an answer because that's a prettier answer. But if you followed my standard advice of rewriting it so it looked like the original problem is a fraction, so I wouldn't take off if anybody gave me that as an answer, because the standard protocol is to return answers as close as possible to the original format. And so someone that was really following that might do that. In this particular case, this is a much prettier answer, so that's probably what you would see. But if someone did that, I wouldn't take off because I have harped on answers should look like the original problem as much as possible. Okay, now I will purposely end this video and we'll go on to the next video, picking up at number 5 there.